What's up, guys? So now we are going to cover 2D arrays in Java. Let's get going. Let's just create a new project and we'll call this 2D arrays. Oh wait, we can't do that. Two-dimensional arrays. Leave all the defaults, add the sample code. If you've not set up IntelliJ yet, make sure to go right back to the start of this series. Here is our code space, and now we are going to do some stuff with two-dimensional arrays. So you're probably thinking, we've learnt arrays already. What is a two-dimensional array? Well, a two-dimensional array is an array inside an array. Pretty simple stuff, right? And 2D arrays are used all the time in everything. And obviously we have, that is a 2D array. Obviously, if you use, your fundamental thinking skills, a 3D array would be an array inside an array inside an array. And obviously, a 4-dimensional array would be an array inside an array inside an array inside an array. Someone try and comment down below how many times I've said the word array in the past 2 minutes. Anyways, we're only going to be covering 2D arrays because the thing is that once you have the fundamentals of 2D arrays, then you can apply that however you want. So some use cases of 2D arrays is if we wanted, a grid, right? A grid is a main example. So, we have the ability to not just have a row or a column, but a row and a column, right? So we can create that in Java by doing this. So int, we'll do it like a normal array, except for after our first set of square brackets, which represents one dimension, we need another one, right? So we'll call this grid equals, and then we can initialize it in the same way with the same type of values we did before, except for we need a list of lists. So I'm just going to create this as empty for now, but let's just press enter. And then now we can basically format our grid in a grid style fashion. So we can go like 3, 2, 1. And then obviously this is an array within this wider array, right? So if I put this all on the same line, you'll be able to see that better, right? And what we can do is we can have a list of arrays, meaning that we can create multiple of these arrays as part of the massive array, right? So we have these 4 subarrays, which contain their own elements, within this one big array. And if we just press enter, which doesn't have any effect on the code, we can just do this for readability. Because Java knows this is the same line because we end each line with a semicolon. Let's just press enter on all of these so that we can basically see the grid, right? So actually we really want a 3x3 grid rather than a 3x4 grid like this. Push that in a bit. There we go. So here we have this grid, right? And we could put different numbers in each one, right? We could go 4, 5, 6, 7, 8, and 9. That represents all the numbers from 1 to 9. All the 1-digit numbers. That's how we create a 2D array. Now, this is very useful because what we can basically do is we can retrieve any of these elements. And how do we retrieve an element from a 2D array? Well, it's similar to a 1D array, except for we would retrieve it by going like this. Grid at index something at index something, right? So, for example, if we wanted to get this element here, 6, we would need to go, okay, so that is index, this is index 0, so it's going to be grid at 0. That's what that's going to be, right? And then, so if we call grid at index 0, that's going to return the array of 3, 2, and 1. But if we do grid at 1, it's going to return the array of 4, 5, and 6, etc., etc. You get the gist, right? Now, That is just to get the subarrays. If we want a specific element in the subarray, we will then need to go like 0, 1, 2. Just like in any other array. So, for example, if we go like this, so we can visually see all of the different indexes for each subarray. So now, in order to get number 6, we want grid at index 1, which is going to be, n is going to be 1, and m is going to be the element of just this array, this subarray. So then this becomes a 1D array, and it means that we could just go at index 2. Because, obviously we start at 0, and that's going to be 1 and 2. So, if we were to try and output system out print grid at 1, 2, then we should hopefully get the value of 6. So now, let's try to find another one. Let's try to find 8. So we first want to find its subarray, which is going to be in the third subarray, meaning that is going to be at index 2 because we start at 0. Now, within this array, which one we were searching for? I think it was either 7 or 8. Let's say 8 is going to be index 1 because we've got 0, 1, 2. We're going to grab that, meaning that 8 is going to be at index 2 at index 1. So that's how we're able to retrieve an individual element from a 2D array. 8, cool. So let's just get rid of all of these comments because they're adding quite a lot of space into this code. So that is the fundamentals of retrieving from a 2D array. Now that's just one piece of the puzzle. To retrieve a number, we need to know where it is. But let's say we want to, iterate over this and print out all of the different numbers in this two-dimensional array. Here's what we do. Let's write a for loop. So it's just like a for loop in a normal array. So we go like for int I, which is going to be the index of our array. So we're going to start that at 0. And the reason we're going to start this at 0 is because obviously, like we did in the retrieval, index 0 is where it starts. I is going to be less than grid.length. And I++ is going to make us increment it each time. Now, if we do system out print grid at index I, we're just going to go through each and every one, then we're going to get a weird output. And we're going to get this weird output of different hash codes and things like that. These are actually very useful, but these are a more advanced topic in Java, so we can go through that later on. So as you can see, we're now printing out these subarrays, which isn't what we want. We want the individual values. So what do? Well, if you try and think about the way this would work, we could put a for loop inside a for loop. And then that would then allow us to treat this like a normal array and iterate over each one. So when we're creating a for loop inside of a for loop, what we call a nested for loop, we have to bear in mind that this takes a lot of time. And obviously we discussed, time in the previous lessons where we had a for loop and a while loop, and it would take, a lot of time. Now, a nested for a while loop takes even longer because we're doing a for loop inside a for loop, which sort of times as the effect by itself, resulting in, whatever this is squared, right? So we end up visiting 9 items, and the length of the grid array is actually 3 because we have 3 subarrays within it. Anyways, now here's what we do. we need another for loop inside of here, except for usually we'd go, int I equals whatever and continue on with our day. But the issue is that this I is already defined in this scope. Because we've got a for loop inside a for loop, we can't use the I name for our counter variable. So the convention is we just use j. Now we can name this whatever we want, but in a lot of codes you'll see I and j used. So we can go j is 0, j is less than grid, and then at index I dot length, and then j plus plus to increment j, and then curly bracket. So then now whatever's in here, we can actually grab the value itself, which is going to be one of these individual items. So this outer for loop here goes through like this, bam, bam, bam. But then each time we then want to grab the sub array here and then get the length of the sub array. And then we want to output grid at I j. Oops. So we have grid ij is going to be 3, 2, 1, 4, 5, 6, 9, whatever. So let's output grid at I at j. And let's see what happens. So then we get 3, 2, 1, 4, 5, 6, 9, 8, 7. That is the right order. 3, 2, 1, 4, 5, 6, 9, 8, 7. It goes, this way from left to right, like that. And if we were to put this all on the same line, which it's up to you how you lay it out, then that is in this order here. So that's how we're able to iterate over a 2D array. Now this will take a lot of time to do computationally. Obviously we don't notice this, but if we had 100 elements, then that would be 100 squared. Because the thing is that if we had 100 of these of length 100, then we would have to do this 100 times this 100 times. And obviously 2D arrays are very useful for different things, and you'll see them many times in computer science. We can also have 3D arrays, which obviously, the principle is the same. We're going to have int like that, 3D, and we could, do that and all of that stuff. But that is out of scope. And as long as you understand the fundamentals, you'll be able to use those fine. So yeah, that is 2D arrays, not 3D arrays. Tune in to the next episode where we're going to cover dynamic lists in Java.